All right, let's take a journey. We're going deep inside the gadgets you use every single day. We're going to tell the story of a tiny and honestly an unsung hero of the digital world, the custom-built computer chip. We'll cover how it gets made, from a simple idea all the way to a finished piece of silicon.
You ever wonder about this? Like, why can your brand new Bitcoin miner crunch numbers at an insane speed, but it can't even browse the web? Or why the chip that makes your phone's photos look so good is so fast at just that one thing? Well, the answer comes down to a really fundamental choice in the world of computer chip design.
So you've got two main players on the field. On one side, you have the CPU in your computer. That's the jack of all trades. Think of it like a family car. It can get you to the grocery store, take the kids to school, go on a road trip. It does a bit of everything pretty well. But then, on the other side, you have the ASIC, the application-specific integrated circuit. This is the master of one. This isn't your family sedan. This is a Formula One race car, built with one single obsessive purpose: to do one thing faster and more efficiently than literally anything else on the planet.
Okay, so we've got the analogy down, but let's get into it. What exactly makes this specialist chip, the ASIC, so special?
Here's the textbook definition for you. The key phrases you really got to latch onto are custom designed and particular use. See, an ASIC isn't meant to be flexible at all. It's hardwired right from birth to do a very specific job and absolutely nothing else.
And trust me, you find them everywhere. That little chip that makes your smartphone pictures look absolutely stunning, that's an ASIC. The absolute engine of a crypto mining rig, a super powerful ASIC. The gear that directs all that internet traffic across the globe, or the really complex systems in modern cars, yep, they all rely on these custom-built brains to do their jobs with just unbelievable efficiency.
So, how does one of these little marvels actually get made? You might think it all starts in a factory, but the real journey begins way before anyone touches a piece of silicon. It all starts in the digital world, with the mission to create the perfect blueprint.
First, you start with what's called a specification. Engineers sit down and define exactly what this chip needs to do, how fast it needs to be, and how much power it can use. Then comes the design, where they actually describe all that logic using a special programming language made just for hardware. It's like they're writing the chip's DNA in code. And what is maybe the most crucial part here is verification. I mean, they run millions, sometimes billions of digital simulations to stress test the design and make absolutely sure this blueprint is flawless. Because once you build it, you can't go back.
After all that testing, the code goes through a process called synthesis. Now this is the magic moment. This is where that human-readable code gets translated into a super detailed map of millions of tiny electronic switches, or gates. In this map, it's called a netlist, and it specifies the exact logic that's going to be physically built right into the chip.
And there's one more really clever step in this blueprint phase. Engineers actually build in special access points and test structures right into the design. It's kind of like adding diagnostic ports to a car engine while it's still just a drawing. Doing this makes it possible to find any tiny manufacturing mistakes later on down the line. It's pretty smart.
Okay, so the blueprint is perfect, it's verified, it's ready to go. Now we move from the digital world to the physical one. This is where we start building what is, for all intents and purposes, a microscopic, hyper-complex city on a tiny sliver of silicon.
The process starts with floor planning. And it's just like it sounds. Like a city planner, engineers decide where the major districts, the big functional blocks of the chip, are going to go. Then they place millions of individual buildings, the standard cells, into position. It's this incredibly complex puzzle of optimizing the layout for space and, of course, for speed.
Now, a city's no good without infrastructure, right? It needs power and roads. So first, a clock tree is created. You can think of this as the city's heartbeat, making sure every single little component acts in perfect sync. Then comes routing, where literally millions of microscopic wires are laid down, connecting every single building and district. These are the roads and highways that data will travel on. Finally, there's one last round of checks, a whole battery of tests to confirm everything will work at speed and that the design can actually be manufactured. And once it passes, it's the moment of truth, tape out. The final design is sent off to the factory, the foundry, to be forged in silicon. This is a multi-million-dollar point of no return, no pressure.
So after that incredibly long, incredibly complex, and super expensive journey, you have to ask the big question, was it all worth it? Because, choosing to build an ASIC is not a simple decision. It is a massive trade-off.
So the advantages are exactly what you'd hope for from a specialist.
You get incredible performance and amazing power efficiency. But that performance gain, it's not a small one. For something like Bitcoin mining, a good ASIC is thousands of times more efficient than a general-purpose chip. That's the huge payoff. But the challenges are just as big. The upfront cost can be millions of dollars, and it takes a really long time to develop. And maybe the biggest drawback? It's completely inflexible. Unlike software, you can't just issue a patch or an update. Once that chip is manufactured, its function is literally set in stone, or, well, in silicon.
So with all those massive challenges, why even bother? Because for the right application, the payoff is just so huge that it makes all the cost and all the difficulty totally worth it. ASICs are what allow our technology to reach the absolute pinnacle of performance.
And this quote really gets to the heart of it. When an application demands that every last drop of speed, every single milliwatt of power is squeezed out of the hardware, there is simply no substitute for a custom-designed ASIC.
They really are the quiet backbone of so many industries. Global telecommunications, the phones and gadgets in your pocket, cryptocurrency, and the world's most powerful computer systems, they all depend on ASICs to push the boundaries of what's even possible.
And that kind of leaves us with a final thought to chew on. As technology like AI, quantum computing, and even biointegration keeps advancing at this incredible pace, you have to wonder, what's going to be the next revolutionary application that is so demanding, so specialized, that it will require its own perfectly tailored, custom-built ASIC to change the world?